All right, we're going to look at compound interest in continuously compounded interest. They have different formulas, and you use them for different scenarios. Um, Compound interest is kind of based off of simple interest, and simple interest is based off of a year and has a different formula. But compound interest is you're earning interest on top of your interest. So after a certain amount of time, you gain some interest, and then after another certain amount of time, you gain interest on your original deposit or loan, and then you gain some interest on interest that you've earned. So compound interest is A equals P, your principal, times 1 plus R over N to the NT power. That's just the formula, so maybe you need to make a flashcard to memorize that. A is going to be the total dollar amount at the end of the loan, or how long you have money in an account. P is the principal, and that's going to be the dollar amount that you deposit or loan. T is time in years. Your interest rate is going to be, you need to change it into a decimal. And then N is the number of compounds per year. And usually what happens is you're going to be given, let's see how many variables we have, 1, 2, 3, 4, 5. You're going to be given 4 out of the 5 variables, and then you just have to use, depending on which variable you're solving for, you'll have to use different methods to solve for it. So for instance, if you're solving for t, you're probably going to want to use a logarithm because t is in the exponent. Okay. Now, if we look at continuously compounded interest, the continuously means we're earning interest all the time. In class, I may have said something silly like, this is the PERT equation for the shampoo PERT. If you want continuously flowing hair, you're going to use PERT shampoo. Anyways, the connection there, and it's silly, is continuous. Again, A stands for total dollar amount. PERT is also used for exponential growth and decay. So that'd be like the final amount of bacteria growth, or however much, if we have exponential decay, how much carbon-14 is left, for instance. P is going to be the principal dollar amount deposited or loaned, or it will be the initial amount of bacteria or radioactive substance or whatever you start out with. R is the interest rate as a decimal, or maybe it's a decay constant or a growth constant. So that information will be given to you, or maybe you have to solve for it. T is in years, and then remember E is 2.71, but don't use 2.71 when you're doing the calculations. Use your calculator's E to the X button. Usually it's E to the X, and it's next to your LN button. All right, let's go ahead and do an example. Let's say I have a principal of $100, and the interest rate is 4%. So as a decimal, percent means per 100, so that would be 4 hundredths, or 0.04. And let's say it's compounded twice a year for 5 years, and I want to know how much do I have after that 5 years. So this is compounded n number of times a year. That would be twice. And you don't see the word continuous anywhere, so we're going to use A equals P 1 plus R over N to the NT. And what I like to do is I just like to write down all my variables and then plug in what I know, and then that will kind of help me figure out what I need to do for the rest of the problem. So the time's given is 5 years, so that's our T. And then they say it's compounded twice per year, that's our N. And they gave us the interest rate and the principal. So the only thing I don't know is what A is, so that's what we're going to try to find. Since the formula's already solved for A, I really just got to plug in and work things out. So this is going to be A equals 100, 1 plus 0.04 over 2, to 2 times 5. And all we're doing here is we're just plugging in for each one of the variables. Okay. And follow order of operations, we'll go ahead and work the parentheses. So this would be 100, 1 plus 0.02 to the 10. So we got the 0.02 by dividing by 2. Alright, so this will be 100, 1.02 to the 10. And just be careful putting it into your calculator. Depending on what type of calculator you have, they'll have a different order of doing them. So if you have any questions, you can always send me an email or ask me in class, or go to tutoring, and the tutors will know how to plug this into your calculator. All right, so after 5 years, I got $121.90. So the interest earned was $21.90. So maybe I can go out and get a cheap dinner or something like that after 5 years. So not the greatest interest in the world, although 4% is a pretty good interest. All right, let's look at another scenario. Let's say that you want to know how long will it take $100 to double if an account is compounded daily at 4% interest. So I don't see the word continuous anywhere, so we're going to use the A equals P1 plus R over N to the NT. Okay, and then we're going to go ahead and write down all our variables, and then we'll start filling in the blanks. So it's asking me how long it will take. So that's going to be a time. So I'm not going to know what time is. So if I don't know time, I should know everything else. For something to double means twice, or so double of 100 would be 200. So I know I'm going to initially deposit $100, or you're going to deposit $100. Your rate is going to be as a decimal, so it'd be 0.04. It is compounded daily, so there's 365 days in a year. Now let's suppose we said compounded monthly. If we said it's compounded monthly, then that would be 12, because there's 12 months in a year. Quarterly would mean 4 times. Biannually or semi-annually would mean twice a year. If they just say annually, that means once a year. And our amount is 200, so we're going to go ahead and plug all of that stuff in. Okay. Now, I'm not going to rewrite 1 plus 0.04 divided by 365 because it's a gross decimal number, and if I carry that around, I'm going to end up rounding, and then I'm not going to get as accurate of a result. So I'm just going to leave that as is, as gross as it looks, but sometimes it just doesn't look nice. This is an exponential. We're solving for the variable t, which is an exponent, so we're going to need to isolate the exponential, so we're going to divide both sides by 100. Now notice, any problem where you're asked when is something doubled, you're always going to end up having 2 equals base and then to its exponent. Every time. Every time. And now I have choices. So you've solved stuff like this before, and now you either are going to log both sides or ln both sides and use the power rule to bring down the 365t, or you can use the definition of log, or rewrite the log in exponential form. No, I said that wrong. Rewrite as log form, excuse me. So you're going to rewrite as log form, and then you need to use change of base. Well, that's what I'm going to do. So your base is that ugly thing, and yeah, your base can be yucky like that. Your argument is 2, and the exponent is 365t. Okay. Now, for lack of real estate, I'm going to do 2 steps here. I'm going to divide by 365. Dividing by 365 is the exact same thing as multiplying by 1 over 365. The second thing I'm going to do is I'm going to use my change of base formula. So change of base is log of the argument divided by log of the base, because most calculators are not going to do the base of 1 plus 0.04 over 365. It just doesn't happen. Some calculators are fancy enough to do that. Okay. Then that 1 over 365 I was talking about, we're going to do that to both sides to get rid of the 365. And then plugging all that junk into the calculator, t is approximately 17.3 years. So that's going to be quite a long time for it to double. Now, maybe if you deposit a bunch, then you'll have more. But 17.3 years is quite a while. 4% interest is fairly good, but not great. Probably better than a lot of the interest rates you're going to get now. We're going to look at one more example here, and let's say we want to know how long it takes for $100 at 4% rate, compounded continuously, and we want to know how long it's going to take for it to double. So because we're saying this is continuously compounded interest, we're going to use the PERT equation. So A equals P e to the RT, and we need to figure out what the A is, the P is, the R, and the T. We don't need to know what E is because that's going to be 2.71 in your calculator. So use the E button, don't use 2.71, you won't have as accurate a result. Okay, we don't know what the time is, that's what we're trying to do, is figure out the double time. Rate is 0.04, principal is 100, and the amount is 200. Okay, so we'll plug everything in, and we want to isolate the exponential. So we're going to divide both sides by 100. So t is equal to 0.04 to the raised to the t power. At this point in time, you can take the natural log of both sides, or you can use the definition of logarithm, which means to write in logarithmic form. So the base here is e. So if the base is e, that's the natural log of 2 is equal to your exponent. Divide both sides by 0.04. And that will be approximately 17.3 years. The decimal is going to be a little bit different from the previous example, but the more compounds the better, so this one would be slightly better than compounding daily.